Hello students, today we are going to take up the topic oxides of nitrogen, their preparation and uses. We will be taking up some structures also. So let us start. Thought for the session is believe in yourself and the world will be at your feet. Swami Vivekananda. So learning outcomes from this session is, so you would be able to explain about the oxides of nitrogen, which include nitrous oxide, nitric oxide, dinitrogen trioxide, dinitrogen tetroxide, and as well as N2O5 also. Preparation of these oxides along with their structures and uses. So let us start. The first oxide is nitrous N2O, that is also known as laughing gas, nitric NO, dinitrogen trioxide, nitrogen dioxide, dinitrogen tetroxide. It is actually dimer of NO2. Similarly, dinitrogen pentoxide N2O5. So here is in the bracket their oxidation state is written. We can calculate by use of X also, like 2X minus 2 is equal to 0. So therefore X is equal to 1. Similarly, X minus 2 is equal to 0. That is equal to X is equal to 2. Similarly, 2X minus 6, 3 into minus 2, minus 6 is equal to 0. So X will be plus 3. This way we can calculate the oxidation numbers also. So more is the oxidation number, more will be the acidic character. So let us summarize this area of the oxidation state we have just calculated, and there are the methods of preparation of these nitrogen oxides and their physical properties. So if you see laughing gas N2O we can produce by heating ammonium nitrate. There we will get N2O plus water, the first reaction here, and this gas is colorless and neutral. So you know that lesser will be the oxidation number, the neutrality will be there. As the oxidation number increases, if you see in case of N2O5 maximum oxidation number, the colorless, solid, acidic. Okay. Similarly, if you want to produce NO, you know that in 10th class also you studied about a ring test, and ring test is due to what? Due to the formation of complex nitrosoferrous sulfate. So this is the reaction in relation to that. When you are going to check the nitrates and you are adding acidified ferrous sulfate, the same thing we are adding here. Nitrite we are adding, that is converted to NO, means reduction of NaNO2 takes place to NO, and thereby we are getting the gas NO, nitric oxide, okay, or nitrogen monoxide. And this gas is also colorless and neutral. So it means plus 1 plus 2 oxidation states are neutral and higher oxidation states are acidic. Let us say further we want to produce N2O3. So how to make that? NO plus N2O4 give rise to N2O3. So this way blue solid, and this is acidic. Similarly, this reaction you have learned so many times and have done in the lab also. Lead nitrate give rise to lead oxide, nitrogen dioxide which is reddish brown in color, and oxygen which is colorless. Lead oxide is reddish brown on heating and yellow on cooling. Okay, similarly nitrogen dioxide, if you cool that gas, it may dimerizes N2O4. Okay, if you heat again, it will change to NO2, colorless, solid and liquid and acidic. So as the molecular mass is increasing, the state of matter is also changing, and that is converted to solid acidic nature. And it's very pertinent to note that here N2O5 we are getting sorry, if we are reacting with the phosphorus oxide, phosphorus tetra P4O10, tetraphosphorus and deca oxide, so we are getting the HPO3 as the acid and N2O5 as the oxide. Okay, so now we want to find out the structures of these oxides. So before that, there is some basic involved, that how many bonds are formed in a particular structure we can calculate by use of this formula. Please try to understand in a very easy manner. So if you are having, for example, nitrous oxide, and you know that nitrogen having 5 valence electron and oxygen is having 6 valence electron, and if the total number of valence electron would be 2 into 5, 1 into 6, so that would be 16, and you know the total 3 atoms are there, 2 for nitrogen and 1 for oxygen, and each have to complete the octet to produce a molecule to get the stability. So 8 into 3, 24. So 24 minus the valence electron, that will comes out to 8. 8 divided by 2 is equal to 4. It means 4 bonds will be formed in case of nitrous oxide. So if you see the structure also, you will find that structure will be having 4 bonds. And how 4 bonds is possible? There are 3 ways. So therefore we are maintaining this Lewis structure. We are drawing these structures. The electrons should be balanced. Therefore positive and negative charge will come accordingly. If you see stability 2 to 4, and oxygen, you know that double bond is formed with oxygen. That's why it is stable. And here is single bond and here triple bond. That's why these both are unstable. Okay. And fine. So here 2 and 2, 4. So because one electron deficient, therefore positive charge. And here 2, 4, 6. And it should be 5 actually. So therefore minus is there. Similarly 2, 4, 6. And here it is 6 electron. That's fine. So therefore no charge. So that's why how means we are able to draw the structure. This will come with practice only, nothing else. So now we have discussed already here ammonium nitrate heating. We are getting a nitrous oxide, and that which is a laughing gas, and the structure will be linear. Now next thing is nitric oxide. So let us calculate the same manner. Nitrogen is 5 and oxygen is 6, total 11, and 2 are there. 2 into 8, 16, and 16 minus 11 is 5. So whenever there is odd number is coming, and what you have to do is you have to, because it represents that there will be some deficiency, that will be incomplete octet, because octet will never complete. So thereby we are reducing 1 here. 5 minus 1 is equal to 4. 4 divided by 2 is equal to bond pair is equal to 2. So in this case the maximum bond pair would be 2. Okay. So let us see how. So we can see this structure. So here 2 bonds are there. This represents the electron shift. Electron shift from oxygen to nitrogen. Okay. Otherwise it's 2 bond is there. So nitric oxide, we have discussed already the ferrous sulfate case. This case, NaNO2, FeSO4, H2SO4 give rise to ferric. Ferrous is converted to ferric, and NaNO2 reduced to NO. So this way we can produce that, and we can produce with this method also. You have done these reactions in class 10th also, and we will do in the nitric acid also again. 3 copper 8 nitric acid dilute. Please remember that it is dilute. Otherwise, if you are using concentrated, NO2 will be produced. Copper nitrate plus water plus NO. Further, these are other reactions, but not a part of our syllabus. So you can focus on either this reaction 1 and this reaction 2. That's all. Okay. So now next thing is in relation to the calculation of number of bonds in case of N2O3, and you can calculate here. Nitrogen is having 5 valence electron, oxygen is having 6 valence electron. 5 into 2 10, and 6 into 3 18. 18 plus 10 28, and number of atoms will be 5 total. 5 into 8 40. 40 minus 28, that will come out to be 12. 12 divided by 2 is equal to 6. So 6 bond pair will be there. So in this structure, next structure which we are going to show you here, please calculate the number of bonds. The number of bonds is 2, 3, 4, 6. So 6 bond. Now the structure will be fine, and we can find it very easily. The basic things also you should keep in mind, that oxygen will be forming double bond. Okay, so this basic concepts we shall be used. Accordingly, we can draw the structures, and here to prepare it is very easy comparatively. And NO plus N2O4 give rise to N2O3 at 250 Kelvin. Okay, so now you can, I will not calculate the number of bonds. You can calculate yourself. If you remember, nitrogen you are having 5 valence electron, oxygen having 6. So 6 into 2 12, 12 plus 5 17. There also odd number is there. Okay, and 3 would be 8, 24. 24 minus 17. So it would be 7. So 7 we don't want. 7 minus 1 6. 6 divided by 2, that is equal to 3. 3 bonds are required. So 3 bonds we have made here. Okay, so this way, and always there will be, the octet will not complete. So that is also the case. So if you see here, nitrogen is having 2 electrons here. See here, nitrogen 2, 3 and 1, 4. So there is incomplete octet in this case also. Okay, so this way we have to draw the structures. It will come with practice only. Okay, so next is regarding to N2O4. N2O4, if you draw the structure of NO2, then you have to do the C. You have drawn the NO2, just tilt it for this 90 degree. What you are finding? N11O and combine both. So this is way how we are done here. Okay, so calculation of number of bonds you can do the same manner. So total bond would be 2, 3, 4, 5 and 7. 7 would be there. You can calculate with the formula you'll find the correct number. Okay. Similarly, and here also next is N2O5. N2O5 again we can calculate, just check it. Nitrogen N2O5, we are having 5 into 6, 6 into 5, 30, 30 plus 40, and total are 7. 7 into 8, 56. 56 minus 40, that will come out to be 16. 16 divided by 2, that is equal to 8. So you can check the number of bonds. 2, 2, 4, 5, 6, 7, 8. Absolutely correct. Okay, so this way we have to calculate and accordingly check. And if you draw, you can draw with the help of NO2 also. See, the NO2 structure is same. NO2 structure is same combined with the oxygen. That's why, means that symbol, that from that also we can derive the structures. Okay. So next is in relation to, this is a summary of all the structures, and you have to prepare that. You see the first and second structure is linear here, then this planar, angular, planar and planar. Okay. So this way we have to draw the structures. Okay. Now the next part is uses. Uses N2O, as earlier I have told you, it is also known as laughing gas. Why? It produces the hysterical laughter. And food additive also, propellant also used additive infused to increase the available oxygen in combustion, because these compounds are particularly used in rocket fuels and in explosives also. Used to dilate muscles, especially in lungs, used for ventilators machine to treat respiratory failure in premature babies. N2O3, special purpose fuels and rocket fuels. Catalyst in oxidation is used as NO2. An inhibitor to prevent the polymerization of acrylates during distillation. Nitrating agent also we are using, oxidizing agent also, rocket fuel, floor bleaching agents. N2O4, oxidizer, propellant with a hydrogen based rocket fuel. This is used in the rocket in space exploration, that rockets we are sending is used propellants. N2O5, oxidizers in rocket fuel, mixture of N2O5 and nitric acid is strong nitrating agent. In case of, you remember that benzene nitration we have done in class 1, that's where these oxides are used there. Okay, so these are the recap of what we have discussed about the oxides, about the preparation, about the structures, and about the properties of colorless gas. Gas here, also solid here, gas, solid, solid. Okay, so this way we have discussed about the structures also, how to calculate the bonds also, that we discussed. And further in relation to that, let us check our understanding which is most acidic. We have to calculate the oxidation number, and where is the oxidation number maximum is in case of N2O5, that is +5. Similarly, which oxide nitrate is obtained from lead nitrate? Lead nitrate, you know that which gas is obtained, and that is dark reddish brown gas, that is NO2. On cooling the above gas, which oxide is formed? You know that dimer is formed. What is the dimer named as? N2O4, dinitrogen tetraoxide. Similarly, if you see which oxide are in neutral, first +1 oxidation state, so that is +1 as well as +2, nitrous and nitric. And the next question is hysterical laughter, that is nitrous oxide. Okay, and next is which oxide nitrate obtained from heating ammonium nitrate, that is N2O, that is the first one. Okay, so this way you motivate yourself that you have done the great job. Okay, so again the thought, believe in yourself and the word will be at your feet. Thank you.